this talk, we're going to revisit some of the most popular, or in my particular opinion, of course, or most important subjects of the book. We're going to see what's new in the latest edition, and maybe I can give you one or more two tips that aren't in the book. Of course, it's a lot of content to cover. I don't intend to show everything in just 50 minutes. There is a longer version of this talk available on YouTube, which is a 3-hour version. But even in 3 hours, I'm not covering everything of the book. I'm just covering more topics that I think they are more relevant. And in my career, I consider Effective Java to be one of the most important books because maybe Effective Java is one of those steps that might take you from, maybe it's one of the requirements from being a developer to being a senior developer. Because it's not an easy book to read. And I thought that when I was in the beginning of my career, I thought that I was a very good Java programmer. You know, young people, they make mistakes. And then I read the book. And I think Effective Java is one of the books that make you humble because after reading that, you realize that you know absolutely nothing. Yeah? But I still have like multiple editions of the book in my library. And even when I have something to do new, for example, if I have to do some serialization stuff, I always go to the book and open it to reread to make sure I don't make any mistakes. So it's a book that you use forever in your Java career, unless there's fixed stuff, for example, serialization. Some fun facts about me. I'm a Brazilian Japanese. I'm 100% Japanese, but I was born in Brazil. I'm also a Java champion and a Microsoft MVP. As far as Google can tell me, I'm still the first and only one. And last tip, I published this book from O'Reilly, Migrating to Microservices Databases. And thanks to Red Hat, they bought the royalties of the electronic version. So if you want a free copy of the book, this is a link. If you go to my Twitter, and my pinned tweet on my profile has a link to the book too. So you have 2 seconds to take a picture. 1, 2. And Effective Java, of course, I already asked about the book. And it's interesting how some of the best practices that you have in our industry are shared between different authors. So I think that minimized mutability, for example, that is presented on the Effective Java book, matches very well some concepts presented in domain-driven design. So if you want to make to minimize mutability or to make your objects immutable, to perform them as value objects and domain-driven design terminology. Or even if you want to make your entities, your domain entities, less mutable, well, in the book you find some tips. I also have another talk on YouTube where I present how can you get these minimized mutability tips and apply that in Java using domain-driven design. But what's new in the latest version of the Effective Java book? Well, in the latest version, Joshua Bloch covers lambdas, streams, optionals, default methods, interfaces, and try with resources. What we're going to try to cover today is some of these concepts. For example, factory methods, and if you're wondering what are these numbers are the sections of the book. So if you go to section number 9, you learn about try with resources and so on. So I've put this section numbers for you as a reference. So we're going to try to cover factory methods, try with resources, equals, hashcode, ToString, comparable. We're also going to try to cover minimize mutability and enums, which is by far my favorite Java feature. Right now it's competing against lambdas and streams, but enums are one of my favorites, all-time favorites. But enough, I know you don't want to see slides about code, you want to see code, so let's try to do some live coding. And a fun fact about today, it has been quite some time that I formatted my machine before coming and I forgot to reinstall my IDE. So when you were just coming, I just downloaded my IDE, installed, then I realized that I didn't renew my license. So I'm using a 30 days evaluation right now. And let's leave it. Okay, so appearance. Okay. I have here my IDE, and let's try to create a new class. So we'll start a new class called PhoneNumber. And let's try to minimize mutability. So phone number would be a value object in our domain model here, would be a value object in domain-driven design terminology. So what does a phone number has? Well, maybe it has a private int area code. It also should have a private int number. And since we're trying to minimize mutability, we also add some final in front of the properties. And why should we try to minimize mutability? My point is that probably when we're developing software and when we find an error, the error is caused by behavior, which means something is wrong in your business logic. These ones are the easiest one to spot because you have a stack trace or have a login statement, it points you to the line where something was wrong, or you can debug that. But the business problems, the errors caused by inconsistent state are by far the worst. So your program is running, you reach now, oh, phone number was never supposed to be negative, but yet it is. So how the hell did my code reach that inconsistent state? And why that happens? Because usually our code has a very large immutable surface. We just design our code, and because of the Java Bean specifications, and most frameworks requires that, we design our code with getters and setters. And whenever you have a setter, any piece of code in your application can change the internal state of your object. So what we're trying to do is we're trying to minimize mutability. Of course, this is the easy way. You can't mute something that is immutable, which is final by default. So if I'm declaring them as mutable, of course, I need to initialize this stuff. So we're going to use the phone number, and then tip number 1. When you have a constructor, prefer factory methods. And why should you be choosing factory methods instead of constructor? First, personal state. I think the syntax for Java for constructors is very ugly. It's one of the ugliest syntax in Java. But we're used to ugly syntax. It's not the main reason. Another reason for you to choose factory methods is that factory methods can have a name. For example, here I'm choosing off, but I could have chosen other names, for example, value off, which is, in the JDK you have a lot of examples, off, value off. It could also be new instance if you know that you're creating a new instance every time, so it could be new instance. But besides having a name, other benefits of factory methods are you don't have to create a new instance every time you return a new object. For example, if you have the new phone number, every time you're creating a new instance. But if you declare off, maybe you can use a cache. Suppose that you have a very expensive computation for phone number, or that phone number consumes a lot of memory in your JVM. Maybe you could implement the flyweight design pattern. So whenever somebody here types the same exact area code and number, you don't have to construct a new object. You go to your cache, to your map, for example, you look if you have that exact same key, and you will always return the same object. So you're saving CPU by not building a new object, and you're saving memory because you're always returning the same instance. If you implemented the flyweight design pattern, you have another benefit, because at runtime, and it's very useful for performance when you know that you're always comparing against the same objects, then you don't need to use the equals method to compare equality. You can use the equals operator, because it's always the same instance. So that's another benefit of using factory methods. Another benefit of using factory methods is that you're not required to even return always the same type. If you're using a constructor, you're always returning phone number. But suppose that you have a new requirement, and now phone numbers you might have different subclasses of phone number. Now you have, because of business requirements, now you have local phone number, and you have international phone numbers, okay? And it depends on the area code that you're passing to your class. If you're using constructors, you have to go your entire source code base and check. Well, right now I'm using new phone number. Does it mean that I need a new international phone number, or do I need a local phone number? So creation logic is scattered across your entire code base. But if you decided that the only methods in your entire code base that can create new instance of phone number is this factory method, then it would be really simple for you to just type, well, if area code, for example, greater than 500, return new international phone number. okay, or something like that. I won't create the class because of lack of time, but or else just return local phone number. So using factory methods allows you to have a better API evolution. You can create subclasses of your class. You can change the way that your code behaves without changing the way that you create your objects. So that's another very nice benefit of factory methods. Here I'm using a class, for example, but since we use since Java 7 or 8, I don't remember quite exactly, you're allowed to have like static methods on interfaces. So even if you decide later, well, phone number, now maybe I need to change phone number to an interface and not a class. Well, you wouldn't have to change your API. You wouldn't be able to implement like in multiple different classes phone number, and your interface would still have the factory methods off. So these are some of the benefits. Okay, and I mentioned inconsistent state. If you have a factory method, the point in which you should check if your state is consistent or not is before creating a new instance. So I could say, well, you could create a precondition, for example, check argument, and say the area code must be greater than 100, and check argument also that the number must be greater than 1,000. So these are some of the preconditions. And here I'm using a class from Google Guava. And I know most people have mixed reactions about Google Guava because they used to break backward compatibility in some cases. But if you look at the source code for these methods, it's super simple. If not expression, return new illegal argument exception, which is the proper exception that should be thrown if you have an illegal argument for your methods. Okay? So let's go back here to phone number. Oh, I even forgot the shortcuts. Phone number. Okay, so you're declaring your preconditions, you can return different types, and that's it for now. So you have few arguments. One of the best practices that I could recommend. An ideal method should have like no arguments, but we know it's very hard because sometimes you need to pass some states. And if you have a factory method that has up to 3 arguments, maybe it's okay to be a factory method. If you have more than that, or if you have optional parameters, for example, you're better served with a builder. So you could use the builder design pattern to be instantiating new objects. And of course, if you go to the book, you have the builder and very nice builder implementation, which I won't be able to cover today for lack of time, but that's an exercise for you. If you have like a lot of state in your object, it might be a smell, because the smaller the state, the better it is for you. But if you really do need a bigger state, then you're better served with a builder. But let's stick to factory methods for now. If you're designing a factory, trying to minimize mutability, the easiest way for you to create an immutable object is by defining everything as final. And you don't need to declare your class as final. We know that many frameworks don't work well with final classes. So instead of that, to be able to create an immutable class, you just need to create a private constructor. And why is that? Because this constructor can only be invoked inside this class. If you create a subclass with mutable state, well, that class will never be able to be instantiated because it's a private constructor. There's no visibility in the subclasses. So that's another practice. Whenever you're trying to create a value object in domain-driven design terminology, you should always be implementing also the equals and hashcode methods. So equals, oh, this is new. Okay. Cancel. Default. Okay, I'll take it and delete it. Okay. So you should be implementing equals and hash codes. One way for you to generate equals and hash code is using your IDE. Okay, as you've seen, some IDEs do that for you automatically. But in the past, I don't have a strong argument against that. But in the past, what happened was when I allowed my team to be using the ID to generate the equals and hash code, it was super common for them to, oh, we added a field to the class, but we forgot to change the equals and hash code. And you would have production errors because, well, people were just lazy. And it just happened, of course, because we didn't have proper tests for equals and hash code. So I think it's okay for you to generate the equals and hash code the way that you want, as long as you know that if you're using that in your code in production, you're using that, for example, to compare collections or something like that, you just implement the proper tests. Okay? But if you want to do just like me, I'm not that old, but I'm an experienced programmer. So I like to do everything by hand. I like to implement my own equals and hash code methods. So one nice way for you to implement an equals and hash code method is, for example, if O instance of phone number, you can say phone number, other receives O, then you can cast, and since Java 7 Plus, we can use objects dot equals this dot area code, other dot area codes, and objects dot equals this dot number and other dot number. Okay? And or else return false. This is a very nice implementation of equals if you don't care about performance. And why is that? Because the equals method, it receives objects as an argument. And we know the area code is a primitive. So every time we're doing this, we're doing boxing and unboxing, which is a very expensive operation in the JVM. So if we know that the types we're comparing are primitive, we should be using the equality operator instead of the equals. So we should be just using equals to other.area code. Okay, this is a more efficient way. I'll just leave the other as is for you to know that there is this other possibility. In the past, we used to have to use libraries, for example, Commons-Lang or Google Guava, to have this very nice method just to check if the first is new, the second is new, or both are new. Right now, we have on the JDK. It's a very nice way for you to see how the JDK evolves slowly. It took many years for them to add this method, but it happens. Okay, so equals and if you know that you're constantly compare the same object with itself, for example, in collections, you want to check if your collection contains your object. A very cheap optimization for your code could be if object equals to this, return true. Okay, it's a one-liner, very cheap optimization if you know that you're constantly compare that into your collections. And I implemented equals. Whenever you implement equals, you also have to implement hash codes. And a very common mistake happened to me like multiple times. You would have your code, like single method. You would get a map. You would add your object in your map. A few lines later, we'll check, does the map contain your object? False. And it's a bug that would hide, like, we spent like many days trying to figure out what was happening in production. Because, of course, it didn't happen every time. But later I just realized that, well, when you're adding your object to collection, to a hash map, for example, it's calling the hash code. Then it's going to get the hash and put on that bucket. But later, you mutate your object states in that same method. And later you check, does the map contain your object? The hash code is different. It's never going to find it. Even though your object is on the collection, the hash code is different. It's going to look up in another bucket. You're never going to find that. So if you're using any kind of object as the key to your hash map, make sure it's immutable. So make sure that you're never going to change the hash code while you're using that map, which is very hard to achieve. That's why I recommend you to always generate an immutable key for using hash maps. And personal experience, I did the mistake multiple times. And if you're using hash codes, the contract is that whenever you're comparing an object with equals, you should use the same properties in your hash code and in the same order. So, for example, a nice implementation of hash code, for example, could be objects.hash, again, a JDK method, object.hash, this area code, this dot number. Okay? Which is, again, a very nice implementation if you don't care about performance because we're boxing and unboxing. If you know that you're constantly using your object in a hash set or as a key to a hash map, another very cheap optimization would be you just go here, refactor, extract introduce constant, no, not constant, field. Okay, you can go here and say private final int hashcode. And this could be computed directly in your constructor. Oh, another good use for fly with. Hashcode seems this one. And instead of computing your hashcode every time, you just return the hashcode that you have. So a very cheap optimization, especially if your class is immutable. Okay? If you don't want to use your IDE, if you don't want to use tools like Lombok or other stuff, you can use, for example, you can look at the book. There, Joshua Bloch provides you a nice implementation of hash methods that provides like a reasonable amount of collisions on big collections. Okay? What else can we show here on this very simple class? We can also provide ToString. And many people mistake that ToString for select no. ToString, many people think that ToString should be a business string. But no, ToString is the method that you as a developer should be using when you want to debug or something, or you want to print that object in a log statement. So ToString is not for business values. For business values, we have another interface in Java to do that. So one possible way for you to be creating ToString, I'm using Guava, but you have many other possibilities. So I can use, for example, ToString helper, and this one is going to add area code. And you can add the area codes. You can also add the number, and ToString. Okay, so I just have this just for you to be able to see how does it work. Let's try to instantiate a new phone number of 1231234 and get a print this out. I'll remove this for now. Let's try to run this guy. Okay, you can see here, phone number, area code, and number 1234. You know the type of the object that you're printing. You have the internal state too, or possibly all the information that you need to debug your code. If something went wrong with production, you go to the log statement. Oh, that's the internal state of my application. So that's a very nice ToString method. Okay, and what about business string? Suppose that you have business requirements. I want to print my phone number as the area code dash number. So let's create a method for that. And not many people are aware of that, but we have, since Java 6, we have an interface called formatable, which is very useful if we want to print business strings. So this interface has only one method, and let's try to do that. Formatter.format. If you ever use the formatter, you know that I could print a digit, dash a digit, and I'll pass area code and number as a parameter. And if you wonder what are these arguments, flags, width, and precision, you have to read it at Java doc. But basically, if you want to internationalize that, if you want to print your string from right to left to right, or if you want to print the string in a language where they write like top to bottom, or where the decimals are dots or commas or something like that, you have all of this information in these flags. So that's how you know how to internationalize your string. That's where you use it. But right now, let's be super simple. It's always area code dash number. So how does it print? Let's see. So instead of I'm going to use a printf, press as a string, and the same phone number. So what is the result? So you can see that the first is the developer string for you to debug. The second is the business string, okay? And since we printed this business value here, you can see that there is a clear separation between the area code and the number. Whenever in any string in your code you provide some separation of values, you have to provide getters and setters for those properties. So since I'm printing area code and number separate, in a separate way, I need to provide the getters and setters. And why is that? Because, you know, developers are super smart. If they realize, oh, the business string, if you look at the business string, you know which one is the area code and which one is the number. Whenever any developer needs the area code, what he or she will do? They will get the business string and they will parse it. Because we know that if you split the string with a dash, the first part is the area code. So you're doing string-based development all over your source code base, but then later, some months later, somebody decides to change the requirements. Now, the business string is not anymore separated by dashes. Now the area code is in parentheses, and you have a blank space. So what happened? Your code compiles, your tests run because you didn't write anyway, and but now when you deploy that thing in production, oh, you have runtime exceptions everywhere because you're trying to parse, and the area code, well, you can't split with a dash anymore. Okay? So whenever your business string provides some kind of value that can be separated, it can be identified, you have to provide your getters and setters. Some people might complain because you're exposing the internal implementation of your classes, but in this case, you don't have a choice. You're already showing that separation in your strings, okay? And another thing that we could add here, phone number, maybe phone numbers could be sorted. So maybe phone numbers could implement, for example, comparable, and they might be comparable to other phone numbers. So whenever I have this, let's try to implement comparable. I have this name and method compare to, which could be a very complicated logic because you had to compare all of your fields. If you have object references, they can be new, the other must not be new, you must implement this kind of thing. So in the past, before Java 8, we would have to use libraries for that. For example, here I'm using Google Guava, just an example. I can use comparison chain for Google Guava to be implemented comparator. So start, I can say compare.area, this area code, o.area code, then compare this .number and no.number, and return the result. Okay, it's no safe if I had object references, and it's return the compare. It's a very nice implementation again. But since we're using Java 8, we don't have to rely on Google Guava anymore. Java 8 provides an even nicer way for me to implement this comparison chain. What can I do? I'll just comment out these codes for you to have as a reference, and I can instead do comparator.comparing. And since I'm using primitives, I can use the primitive version comparing int. Well, first, phone number, P. First, I want to compare the area code. Then comparing int, I want to compare p.number. And after I created this comparator, I can ask this comparator, well, compare this object to the other objects. Okay? So if you're using Java 8, this is the new, better version of implementing the comparable interface. You're creating a comparator that first compares the area code and then compares the number. What is the problem with this implementation? Every time you're running the comparator method, you're creating a new instance, actually two instances of comparator. How can we optimize that? These instances are thread safes. So what can we do? I can create a field here. I can create a private static final comparator of phone number, which is going to be, and receive this thing. Okay, so I'm going to reuse this guy every time and return comparator.compare this. Okay, this is the Java 8 Plus of you to create a comparator that is very efficient and is using the Java 8 Plus features and is using lambdas too, right? If you want to be one of the cool kids these days, everything must be a lambda. That's it. And I guess that's what I had to show for now for this basic class. Let's go back to the few slides I have left. Functional interfaces. Java 8 also provides us, of course, lambdas and functional interfaces. So whenever you want to use lambda, you need that method to use a functional interface. What is a function interface? A function interface is an interface that has only one abstract method. So if you stick to that, you have a function interface, you will be able to use a lambda. But function interfaces also allowed us to rethink about some design patterns, the way that we've been implementing design patterns the past 20 plus years. So if in the past, the Java template method pattern Well, in Java it's called idiom because it's a specific implementation of the pattern. But the template method design pattern now in Java should be replaced by the strategy design pattern because, well, function interfaces and lambdas makes it much easier for you to implement strategy than template method. How does it work? Let's see a code. So if I go back here to my code and I decide to create a new function interface, I even have implemented here already. So I have a new function interface, and whenever you're creating your own function interface, you should always add this annotation at function interface. For example, you should type public void do something, which is the worst possible interface you can create because you create an interface with a method that receives nothing and returns nothing. Which means that this interface has only one possible use case. You're only changing internal states. This is how you design a bad API, but it's just a demo, right? So it's a function interface. And why you should be annotating with at function interface? Well, suppose that later, which could be some developer, which could be you, like 2 weeks later, you decided, well, I have a function interface. Wouldn't it be nice if this interface had this other method too? So you just create another useless method, do other thing. And now, everywhere where you were using lambdas with this interface, your code doesn't compile anymore. But it could be even worse. You're not using your interface in your code. You are just a library developer. So the consumers of your API are other teams and other developers. So you decided, oh, everything compiles perfectly. Everything's working fine. My tests are fine because they're non-existent. And you deploy the new version of your library. People update the library, and nothing compiles anymore because it's not a functional interface you can't use in a Lambda. But if you're being wise, you added that function interface, and now your code won't compile because it's warning you, well, you designed this to be a function interface. You can't add another abstract methods. Okay? So this is one of the very few cases where you would use that, because another recommendation from the Effective Java book is that whenever you're thinking about creating a function interface, usually don't. And why is that? Last time I counted, I believe there are 48 or something, 40 plus function interfaces on the JDK, which is a lot for you to learn to. How many of you know all of them? Me neither. Okay? So, but they cover almost every single use case that you might need for functional interfaces. They would cover like 90% plus of the use cases. So instead of creating a new interface that your colleague must learn to be able to use your code, why don't you reuse one of the interfaces that are available on the JDK? You have a fewer surface to test. You have fewer APIs to be able to learn. So always try to reuse the ones that are on the JDK. But luckily, of that 40 plus interfaces, function interface that we have in the JDK, we only have to learn 6 of them. These 6 ones. Because all the other ones are variants for primitive types. So you have unary operator. You have int unary operator. You have long unary operator. You have Boolean unary operator. You have double unary operator. You get a pattern, right? So if you learn one of them, you learn the others because the others are variants for primitive types. So what is a unary operator? Unary operator is an interface that receives one argument of type T and returns the same type. Binary operator, you can guess, receives 2 arguments of type T and returns the same type T. Predicate is something that receives an argument of type T and returns either true or false. You probably used most of these interfaces in your streams APIs already. Function. Function is something that usually is used to transform one object into other. So it receives type T and returns type R. You use this in map operations in collections, for example. Supplier is something that receives nothing, no arguments, and creates something from scratch. And consumer is an interface that receives type T and returns voids. Whenever you have a collection in type, for example, for each, you're using a consumer because you want to just consume. You don't want to return anything else. Okay? Function interfaces. So let's get back here to code. And how can we use this? Let's try to create here, and I'll delete these classes because I forgot to. For example, let's try to create first with template methods. So I'm going to create a new class, my template logic. And suppose here that you have public void do something. You have a method, and you have certain business logic which requires you to do something, very complicated business logic, before and after your methods, okay? But these particular parts can vary. So depending on your business implementation, this particular part changes, but the before part and the after part are always the same. So what would you do? You would create a template methods. For example, public void the other thing. And please forgive me for the bad names, but it's just an example. So it's a template logic, and this method is abstract. So you wouldn't provide an implementation, and your class would also be abstract. So here, what do? You call the do other thing. Okay? So how do you implement the template logic? Whenever you have, for example, I'll do that on the same file, class my other template logic extends my template logic. Okay, and I implement the do other thing methods, which is going to print out C. But if I decided that, oh, maybe I need another implementation, you just create another class, my other template logic 2, super nice name, and you declare D. So let's try to run this thing. I can create a new my other template logic dot do something, and logic to do something. So if I try to run this thing, you can see that here I have a C and here I have a D. That's how you implement common things that must be implemented before and after, and you have something that changes in your implementation, template methods. That's what we would be doing until Java 7. With Java 8, we have a better version of this solution. So instead of using the template method design pattern, we're going to use a strategy. So it's going to be my strategy logic. So suppose that I have to do something. And again, I have the very complicated business logic here and another very complicated business logic here. And this part changes. But let's make it even simpler. Suppose that this part just prints a different string. So what I'm going to do? I'm going to do a printer line, and I'm going to use a consumer. So I'm going to declare here, a supplier of string supplier. And here I'm going to be supplier dot get. So since it knows that add constructor, and since I have a constructor, I can use a refactor to create a factory method too. Okay, so how does the implementation work? Now if I want to use this strategy logic, let's create a main method. I would say my strategy logic, if you want to print C, you could provide, for example, a lambda. If you want to print a B, you would print it this way. So let's run this thing. Oh, it's not doing anything. Do something. Here, do something again. Here I have a C, and here I have a D, and I have the common operations in between. So it's exactly the same result, but my argument, I might agree with Joshua Bloch on this one, this implementation is much nicer than the template method implementation that we used to have until Java 7. Okay? What else? Oh, we all use it to lambdas right now, and let me try so we can do that over here. So we all use it to lambdas in our methods, but in Java 8, we also added another syntax sugar, which is method references. And according to the book, you probably should be using method references instead of lambdas most of the time. At runtime, they're almost the same, in most of the cases. And the syntax is simpler. Once you get used to that, it's easier for you to understand what's happening. And just to make our life harder, we have 5 different types of method reference in the Java language. These are static method references, you have bounded method reference, you have unbounded method reference, you have constructor method reference, and array method references. So how do we use them? So let's start with the simplest possible one. I have an example here, and this particular method requires a function which receives a string and returns an integer. So a very good candidate would be integer.parseInt to create this int for me. So if I'm receiving a string, I could implement as a lambda. I could say integer.parseInt s, and it works. You can see that most IDEs, for example, my ID here, is even suggesting me a refactor. So why don't you replace this lambda with a method reference? And you see the syntax for a method reference is integer, colon, colon, parseInt, because I'm calling a static method on the integer class. Okay? So, and we might argue that, well, this version is simpler and easier to read once you get used to the syntax. Next type of method reference, this is the simplest possible one, static. Now let's go to the most complicated one, bounded method reference. And how does it work? I have a bounded method reference here, and this method requires a predicate of instance, which means it receives an instance and returns either true or false. Let's try to implement that. So instance, and I'm going to say I'm going to call this class instance. I'll call this static method now, and I'll call this method here. Okay? So this is a lambda. How do I convert that to a method reference? And beware, these 2 versions are not bytecode equivalent. Okay, that's why my IDE doesn't suggest to refactor automatically. So what I do is that I could say instance dot now colon colon is after. So this is the method reference. So what am I doing? Why is it bounded? Why is this a bounded method reference? Because I want to invoke this method is after on the particular instance that is being returned by these other methods. So the invocation is bounded to a particular object instance. Okay? So this is the bounded method reference. This is the most complicated one. And to be completely honest with you, I never used this kind of method reference except for when doing this presentation. Okay? So I don't expect you to be seeing this kind of method reference. You have a bounded. The next one is unbounded. Here I have an unary operator which will receive a string and return a string. For example, I could say I'm receiving a string and I want to translate that to lowercase. My IDE is recommending that I translate that to a method reference. String colon colon to lowercase. And why is it unbounded? Because it doesn't matter which instance you're passing me, I'm always going to invoke this method on the instance that I'm receiving. Unbounded. Next one. Constructor method reference. Here you can see that I have a supplier of tree map string string. So I have to create a new tree map. So how does this work? I receive nothing, I have an empty lambda, and I return a new tree map. Okay? And thanks to Java's type inference, I don't need to type string string because the signature already has the types. How do I refactor that? The method reference is tree map colon colon new. We might argue, and I agree with this one completely, this syntax is much cleaner for you to understand. Okay? This is a constructor method reference. And last one, array. Here I have a function, I receive an integer, and I need to return an array of int. So how does it work? I receive an integer, and I need to return a new array of type int. How does it work with method references? Int, brackets, colon, colon, new. I think this syntax is also simpler and easier to understand. Okay? These are the 5 different types of method reference that I have to show. And just to finish, because I'm almost over time, let's try to use Enum. So I'm going to create a new Enum called operation. And Well, I read about these enums on the second edition of the Effective Java book. And to be honest, I read this on a weekend. And the first time I went in the morning into the office was, I need to find something, some ticket, some piece of code that requires an enum. And it didn't, but I solved that with an enum too. So, because I wanted to brag to my colleagues, look what we can do with enum. So, and if you show this to a C# developer, he or she would say, oh, enums are just boring because with C#, they're just placeholders for constants. In Java, they are full-featured classes. So how can you develop, for example, a polymorphic enum? Suppose that we're creating this operation, and I have here add and subtract operations just to be simple. And I say that, well, depending on what I'm doing, I want to add or subtract on the integer. So how can I create a polymorphic enum? I can say protected or public abstract int compute. I have an int x, int y, and it's abstract. So what can I do? Since here I'm declaring and instantiating the enum at the same time, I can override this method into each one of those enums. So what can I do? I can say that I can open here and I say the add implementation should be compute return x plus y. And the subtract operation could be compute x minus y. And I might argue that this is one of the most beautiful things that you can do in Java language. If you want to brag yourself to the others, just show this enum. If he or she didn't read Effective Java, of course. This is one of the most powerful things that we can do with enums. You have limited instantiability. You can limit the operations that can be used in your code. You're implementing their polymorphic. The downside is that enums should be stateless. So all the state that you need for operation should be passed as arguments, but this is not a bad practice, okay? Stateless code most of the times is easier for you to maintain. But this is the pre-Java 8 version. How can we make this code, for example, Lambda friendly? How can we make the Java 8 version of this code? We could, instead of declaring abstracts methods, we will provide implementations. And think about that. If I'm receiving two arguments of the same type and returning the same type, I can use a function interface for that. I can use a int binary operator. And I can declare, yes, enums can have constructors. I can declare a constructor instead of using abstract as a return operator, apply as int x and y. And how does it change my code here? Instead of overriding, I just pass a new lambda. Could be, since it's a binary operator, I have two lambdas, and it's going to return x plus y. And the subtract one, instead of implementing again, I'm going to x and y, and return x minus y. Okay? And I think you might agree with me that this version is much more elegant. We're using the strategy pattern again that I've shown in the other example. This is the strategy pattern. And you might be also saying, you're only capable of doing this very nice enum because your business logic is super simple. That's why you can do everything in a lambda in one-liner. No, you're not limited to that. Suppose that adding these two integers were a very complicated business operation. What can you do? You create another class. I'm going to create a class called sum, and I'm going to create a very complicated business method called int add. Okay, and suppose that this method would perform like super complicated computations that would span through like 1,000 lines, and in the end it will return plus t. Okay, and you have this method. How do I use that on my enum? You can go back here to operation and operation. Yes, so you replace this thing with sum colon add. So it doesn't matter how big is your business logic. You still can use enums. Okay. And the last thing, because now I'm out of time, and just in case, most people already know that, but just in case you don't remember, the best way for you to create a singleton in the Java language since Java 5, I already have it, is by declaring an enum. So public enum singleton, and you declare just a single instance. Not anymore. Don't declare that public static final singleton instance, blah, 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 and you implement a get instance method. No. The easiest way for you is to generate an enum and declare everything here. It can be even stateful. You can have like a private string. Name. You can generate getters and setters for that. Okay. So it's a full-feature singleton. As I said before, enums in Java are full-feature classes. You have all the properties, but with the benefit that you guarantee that you will only have one single instance in your entire JVM. What is the problem with the other implementation? The other implementation fails when you have serialization. So if you implement that and you serialize that object, when you return that object from the serialization stream, you have a new instance. So now your code has two instances of the same class. So if you want to prevent this kind of bug, you have to code your serialization methods properly, which is super complicated. You don't want to do that. You want to use a singleton. Okay? And I'm already over time because the other speaker is already here. And that's what I had to show you today. Thank you very much.